Alright guys, I'm going to make a series of videos to go over the math portion of Lab 2. Some of you were getting really discouraged, and I noticed that a lot of people did not complete the number 9 on your review. And just from hearing feedback, I think you just still don't understand the math. So I want to kind of take it back to the beginning and go through how to use this metrics prefix table. I think that is probably the most confusing part of doing metric system. And I want to teach this to you correctly. I want to make sure that you're understanding why you're doing the math the way you're doing it. So I want to go back and again, I'm going to break this into probably 2 videos. The first one's going to go over the fundamentals of using this table. And the second one is going to be the math for question number 9. And depending on the size, I may have to break that one into a couple of videos, so we'll just kind of see how it goes. But again, this is just going to be a video going over how to use this table. If you're not confused about how to use this table, then do not watch this one, go to the next one. Alright, so here goes. What I want to do is look at an example problem. And from there, let's take a look. Let's do a problem that says 3.5 meters to centimeters. Let's first discuss what a base unit is, because I think that is sometimes confusing. Base unit, what is that? This is a base unit, that is meters. So here's base unit. And in this particular situation, the base unit is going to be meters. Now, here's another thing that's confusing. Meters is often abbreviated as M, but so is milli, all right? The trick is, milli will never be written by itself. So anytime you see an M by itself, it always means meters, okay? So just kind of keep that in mind. And as for this guy here is your prefix. So everything is your list of prefixes as words, and this is the abbreviation or the symbol for that particular prefix. So here is what we're looking at here, centimeter, all right? So let's take a look for a second, and I'm going to clear all this stuff off so we can really be able to take a look at our table. Now, this table can tell you 2 things, and it just depends on how you look at it. For me, I like to ignore the negatives, but I know that a lot of you were like, ignore the negatives? That really doesn't make sense. If I'm going to ignore the negatives, why are they in the table? Let me show you what I mean by ignore the negatives. I mentioned it in class, but I want to just I did not give you an elaborate explanation because of time, so now I have unlimited time, which I'm going to not take this unlimited time, but I want to tell you about what I mean. So what this table will tell you, really this table is telling you that there are 10 to the negative 2 meters in 1 centimeter. That is how this table is actually supposed to be read. So I would say 10 to the negative 2 meters in 1 centimeter. Okay, that is often confusing. I don't know why. A lot of people don't like to write it like this. Or 0.001 meters for every 1 centimeter. That is what this table here is telling you, okay? But remember, and if this makes sense, go with this. So let's actually interpret the table and do this problem with this math here. So what you would do is you'd say 3.5 meters, and then you do your railroad track here, okay? Meters, we're going from meters to centimeters. So meters needs to go on the bottom so we can cancel it out. So, and then use either one of these, because if you put 10 to the negative 2 in your calculator, you're going to get back 1.001. So this is the same exact thing. It's just one's written in scientific notation. The scientific notation to me is cleaner, so I'm going to use that just for the sake of making this look cleaner. All right, we cannot switch it up, so we have to say for every 1 centimeter, there's 10 to the negative 2. All right, if you put this information in your calculator, you say 3.15 divide, or you can say 3.15 times 1 divided by 10 to the negative 2, you're going to get back from your calculator 3.5 times 10 to the power of 2 centimeters. I didn't do that in my calculator. Let's see what it actually says. If you do not want to put this in scientific notation, I'm going to avoid head math here, which is also equal to 350 centimeters. Final answer. Okay. Now, notice you can never deviate from this. All right. You can't say anything other. You have to always keep it this way. 1 centimeter is equal to 10 to the negative 2 meters. That is what this math is telling you. All right. So that's basically using it the negatives. If you want to use it the way I was teaching you in class, let's take a look at it. So that's again going to be using this method. So let's take a look. I'm going to delete this off. Delete. And delete. I like to me, when I think about, and I think I like to take this as a logistical approach. If in your brain, when you process this math, if what I just wrote makes 100% sense to you, stop watching and go to the next video, okay? In my mind, I'm like, well, centimeters is so small. I don't know. In my head, I just automatically think centi, and I think 100. And that's essentially what 10 to the power of 2 is. So you would say, for every 1 meter, there's 100 centimeters, okay? Or for every 1 meter, there's 10 to the 2 centimeters. I prefer this method, and it's just my preference. That is why I say ignore the negatives. So if you're going to use the negatives, they have to go with the base unit. If you're going to use positive integers, you have to use it like this. So it's either this or 10 to the negative 2 meters is equal to 1 centimeter. This is all the same thing. It's like writing, it's just all of it is the same. I forgot my meter there. It's equal to 1 centimeter. These are the same thing. It's just different ways to write the same thing. Long story short, if you want to use the negatives, you have to use what's written in blue. If you do not wish to use the negatives, you have to just pick a way and go with it. I like the red way. That's my preference. It's really up to how you see the math and how you learn it. So choose a way. Let's do it in the red way. So I'm going to get rid of the blue, and I'm going to do the math using the red numbers this time. I just like to have a rhyme and reason. I like the idea of putting 1 next to the larger unit. That's why I use the numbers in red. So if we do 3.5 meters, here's your train track. Meters is going to go on the bottom, centimeters is going to go on the top. Here I can logistically say, all right, 1 goes next to the larger. What's larger? Meters is larger than a centimeter. So centi we know is 100. So 100 here. And then you get 350 centimeters. When you're familiar enough with the math, you can really do it either way. Either way is fine with me. Just get the right answer. But if you're literally going to use what's from the table, please do it in the blue, like I showed you earlier, in blue. If you prefer the method that I showed you in class with leaving off the negatives, you need to do it in this red way here. Let's see how I did the red numbers. I'm going to go through the problems now from question number 9. If you're still having questions, actually maybe let's just do one more. Let's take a look and do one more problem. I'm going to clear all this off. What I want you to do is, let's choose a problem. Let's go a little bit. Let's do this one. I'm going to take a look at this one. Actually, this is a little easier, but we'll kind of baby step into this, into milliliters. All right, so pause the video and do this problem and then come back to it. All right, please don't just move the decimal place because you're not really getting the point of the video. Do the math out and show me how you're doing the math, okay? So I'm going to do it both ways. Pause the video and come back to it. All right, so for me, I'd say do it this way. This is my preferred setup. And you're going to get 2,000 milliliters, all right? But if you want to do it the blue way that we looked at earlier, 2 liters, okay? We would say here, remember if we're looking at our table, milli is to the -3, so that would go down here. There's 10 to the -3 liters in 1 milliliter. Okay, and that still gives you here. So in this particular situation, the prefix goes opposite of where the prefix is, if that makes sense. So if this tells you 1 milliliter is equal to 10 to the -3 liters. All right, so same problem, different ways to approach it. So it really is up to you and how you see the table. All right, hope that helps. So see you in the next video.